Hello, in this video we're going to be showing you how to use the motion analysis and simulation functionality within Inventor. The model I've got on the screen is a little radio controlled car, and we can see we've got all of our assembled components and they're all constrained together. I'm going to assume for the moment that everyone understands the constraints that are used in Inventor. So we've got mate constraints, centerline constraints, etc, etc. What we can do once we've fully constrained our model is simply open up, say, a section of this. So we're going to open up our wishbone and suspension assembly. We can then go along the tabs at the top here and we can choose different environments. So for example, one of them would be dynamic simulation, another one we're going to be using will be the stress analysis area. If we just drop straight into dynamic simulation, what Inventor will do automatically is take all of our constraints that we've used in the assembly and convert them into real-world joints. We can see down the side here, if I just expand my browser here, we've got revolution joints, welded joints that can't move, spherical joints. You can see them being highlighted on the screen as we go along there. And again, these are just simply from the initial constraints that we put on each of those components. If you want, you can manually put these on. We can go to our simulation settings and we can tell Inventor to not put constraints on or to warn us when it's been over constrained, etc, etc. You can display all the degrees of freedom on each of the components as much as you wish there. Now if you want to, we can actually come out of our simulation mode, which is going to go into our construction environment, and here we can actually choose whether we want to insert extra joints or constrain extra components. If we go to our insert joint tab, we can see here we've got a complete library of joints we can put on. We've got revolution joints, prismatic joints, and you get a little window that shows you what this joint is actually going to do, degrees of freedom on each of the joints, etc. We can even go down to spatial joints, so it's just two components being aware of their 3D existence. This can be good for when you're analysing contacts between components. We can add springs, gears, joints, drive belts, etc, etc. So you've got a whole host of components and joints that you can place into your model. As I say, I'm just going to go with the standard joints that have been created from my constraints directly from Inventor. The only thing I have added is a spring. If I just double click on here, it's a simple case of saying we want a spring joint in there, and here we can assign stiffness, the free length of the spring, and the damping, etc. The next area on the dialog box is purely for the view of the spring, so we've got the facets, the amount of turns, the wire radius, etc. And from that information, Inventor will now create a spring for us automatically. Once we've done that, we can simply run the simulation. We're just going to add the forces on there. We just got it pushing up and down. And again, just to show you how that force is working, we go back to our construction environment. We've got several choices on how we actually add forces to our assembly. I've gone for the graph here, and it's just saying at the end of this component, we can see the vertical arrow there, I want to start off with 0 force. I want to go up to 13 newtons, back down to 0, back up to 13, etc. as we go up and down. So it's just going to work the suspension up and down as we go along. We can just put a fixed force in there if we want, just put a constant value in. It's up to you how you want to work with this. I'm going to go for the motion that bounces it up and down, and then we can see how that actually works on the screen. Now it's actually moving the components as you'd expect. It's compressing the spring, but more importantly, it's actually producing some data in the background. So we go to a graph here, we can select any of those components, any of the joints, and actually look at the forces that are acting on each of those components. So here we can see another graph that's been produced where it's going up and down. We've got maximum and minimum loads. If we double click on each of the components, you can just see in the background, if I just minimize this down a little bit, the assembly will actually move to that point in the animation so we can see what's actually happening. What we want to do is find the maximum point of compression on the spring and then add those forces into one of the components so we can do a stress analysis. Very, very simple to do. All we do is right click in our dialog box and just say search for the max. That finds the maximum point of stress. We can then select this and say we want to output all of the stresses that are involved in that segment of the time step and put them into this component and say OK. With that done, we can simply open up the single component in its own window, like so. We can then go to our environments and we just say we want to start a new stress analysis. Now we've done all of the forces in the component via our motion simulation. So what we can do is tell Inventor to add those loads automatically into the part. Now you can see all of the loads have been added. The only thing I need to add, because I've opened this in its own environment, so it's not actually fixed down to the other components, is I just want to say I want to fix these two faces here. So it's just got something to push against. Once that's done, we can then run the simulation, or we can have a quick look at our mesh mode. Just take a few seconds just to add the mesh onto the component. And here we can actually refine certain areas of the mesh if you've got a particular area where you want some detail. I'm just going to go with the standard mesh and then just hit my simulate button. I can then run this. It's going to do the meshing again. It's going to add the forces, look at the loads and constraints, and then give us a complete set of results. So you see, done very, very quickly. Got our standard loadings there. We can go for principal stresses, displacement, which is an important one, so we can see what's actually moving there. I'm just going to turn the mesh off so we can see a little bit clearer. And safety factor, as you can see, is very, very important. We can actually animate this if we wish. So we can see the thing actually flexing. We could save that as a Windows AVI, send it out to somebody, say, need some feedback on this. We can see that we've got a definite problem, so if we wanted to, we could just thicken up this component and then rerun the stresses if we wanted to. At any time we can add a probe, and it might be a particular area we want to know exactly how far this is actually moving, so we can just go add our probing here, and all we want to do, click on this edge, and it's now going to tell us, if we go for displacement, how far that is actually moving. So we can see it's moving just over 0.5 millimeter. The probes will update to whatever screen you're looking at, so we're looking at principal stress, megapascals, displacement, it'll go in millimeters. You can add as many probes as you wish in as many areas as you wish. You can see they'll move around, so you can actually see what's going on there. So again, very, very easy to produce a detailed stress analysis report of your components you're working with, all worked on the original stresses or the original constraints put into your assembly. With that, I hope you enjoyed that, and thank you very much.